Hello and welcome to another Solana tutorial. This is part 6 of the Solana development course, and today we're gonna talk about page order and filter custom account data. This is the last part of module 1, and then we will finally get to program. But first, let's jump in here. And again, I'm gonna hide down here in this corner. Okay, so what are we gonna learn today? We're gonna page order and filter accounts. Yeah, I mean, that was the title of this entire thing. Cool. We're gonna prefetch accounts without data. That's cool. So just, getting the accounts and not retrieving all the data for it, because if we always retrieve all the data, that's like a lot of data if you have a lot of accounts. Determine whether an account's buffer layout specific data is stored. Prefetch account with a subset of data that can be used to order account. Interesting, so we don't get the entire data and we don't get no data, we get a bit of data. I've never done this before either. Fetch only accounts whose data matches specific criteria. Now I've done that before, but always good to repeat and learn how to do that. And then we fetch a subset of total accounts using getMultipleAccounts, because we might not want to load all of them, but just some. I guess it makes sense why we do all that. Remember last time when we did this movie app, we loaded literally all of the accounts. So everybody who stored anything on chain, we loaded it into our review section, and we might want to be a bit more specific and just load, our stuff maybe. I don't know. So that's what we're gonna do today. Let's start.
This lesson delves into some functionality of the RPC calls that we used in the deserializing account data lesson.
Yeah, so it's all about RPC calls here. We're still in the front end and we're still just query accounts. So we query the state of Solana, and that's all just RPC calls. Remote procedure calls. I'm always like, do you really add the calls? And then I'm confused at how you call it. James calls it RPC calls, so let's call it RPC calls.
To save on compute time, you can fetch a large number of accounts without their data by filtering them to return just an array of public keys.
So we don't want all of them, we just want a few.
Once you have a filtered list of public keys, you can order them and fetch the account data they belong to.
So we get just the public keys, and then just the ones that we want to actually retrieve, we then get the actual data, what's stored in the account.
You may have noticed in the last lesson that while we could fetch and display a list of account data, we didn't have any granular control over how many accounts to fetch or their order. In this lesson, we'll learn about some configuration options for the getProgramAccounts function that will enable things like paging, ordering accounts, and filtering.
Especially the filtering can be very helpful. But once again, to reiterate, this is all done by the RPC. Thus, your RPC provider might not support that, right? Because the RPC itself has to do the paging, ordering, and filtering. And that is, again, compute that the RPC needs to do. The RPC needs to go through all the accounts and filter which ones you want to query. So they need to go through all that data anyway, right? It's not like we save a lot. We just save transmission, right? We don't receive all the data that we don't need, but the RPC server still needs to go through it. So again, not super efficient, and personally, still staying with it. If we can avoid to use getProgramAccounts, we should totally avoid getting program accounts. Just have another layout of your accounts such that you always know which accounts you want to retrieve. But, not always possible. If it's not possible, or if we just want to do some debugging, it's definitely good to know how this works. Debugging is a good purpose actually to use this sort of stuff. So there are reasons. Just saying that a production app with like a lot of accounts should not use that anymore. So here it says pretty much what I said. We save the data being transmitted. In his example, he's talking about 2 gigabytes of account data that he would need to download. That we save. But again, the RPC needs to still go through the data. So what do we want? We can provide this data slice option where we say we just want a specific part of the account. And there we just provide the offset and the length. Pretty self-explanatory. We say where we want to start, and we say how much we want. Last time we sliced the buffer when we had it in front end. This time the RPC does the slicing and just gives us the slice. When you include data slice in the configuration, the function will only return the subset of the data buffer that you specified. Okay, so that's data slice. Obviously, we don't want to download all the 2 gigabytes, and maybe we can't even download all of that in one connect, right? If we were to get a JSON that contains data of 2 gigabytes, that's quite a lot, and that might not even work, especially if we're talking about even more data. So we might just want to get the keys and then dynamically get the account data when we need it. So when the user clicks to the next page, then we load that account data. So code! We get program accounts and we provide the data slice with offset 0 and length 0. And as soon as we have length 0, we don't get any data back, right? Because we want a slice of length 0. So give us nothing, but give us the key. So let's actually try that. So remember last time we used the getProgramAccounts to get all of the program accounts from this program ID that we specified here. In this case, this was the student's program, right? Let's just check if this still works. Boom, there we have all of the accounts, and we see that it's initialized, and Arnish is trying to learn Solana to build all the things NFT. Learning Solana to build all things NFT. Makes sense. And he also wants speed. But that's a lot of data that we had to download here. Somebody even put an emoji in here. We're all gonna make it. And I don't want that anymore, right? I want just the keys. I'm just interested in this part. So I provide a slice like this. So in program accounts, let's have a look in the documentation. We had the program ID and we can have a config or commitment, right? You can either have that or that. And in this case, we provide the config. So it's a get program accounts config. Now we can have a look at what a get program accounts config contains. Get program accounts. It allows me to also do a commitment just so I can provide both. The data slice, this is exactly what we want. And then we can also provide encoding filters and a minimum context slot. But in this case, we just want the data slice. And it looks like this. We want the data slice with offset 0 and length 0. And then we can put this config in here. And boom, if I now execute this, I will of course not be able to decode the account anymore. Well, let's leave it in and see what happens. Buffer out of bounds. Well, obviously I'm trying to decode a buffer that is empty, that has length 0. So let's not do that and execute it again. Boom. There we see we get all of the accounts and we still have the buffer, but it's empty. We don't receive any of the data actually that is stored in the account. We just get the public keys for all the accounts, which is cool because we can now decide which ones of those we want to actually load the data for. Yeah, we can then just get all of the accounts by mapping this. And this time map is correct because for each of the accounts, we want the pub key. We get the pub key back. So the list of pub keys we get back. So that's a map. We map account info to public keys. And it's not like we just do something for each account like we have here. So that's why here I have a for each. I mean, you can do this with map. It does the same thing, but conceptually it should be a for each. I'm picky on naming stuff because that makes code easily readable. So we can also do that, right? Like if we want the accounts like he does, we would get from the accounts, which is the account info, we map each account onto the account pub key. And then we would have the list of public keys, right? So it tells us this is a list of public key. With this list of keys, you can then fetch account data in pages using getMultipleAccountsInfo method. Get account info without the multiple. We've seen that. That's what we use to get the account info for one account. And with multiple, we can do it for multiple accounts. Who would have thought that this actually works? Now what we do is the get multiple accounts info. There we just provide the keys that we want to get. We can do this here. For the paginated keys, he essentially just takes the first 10 accounts. We make the paging manually, say 10 per page. So we receive the first 10 accounts here. Why not? Right? So we have all of the accounts, get 10 of them, and then we get multiple account info, which pretty much returns the same as get account info, but an array of that, right? So an account info buffer array. And then that array, we can do the things with the deserialization that we did up here and log the initialized name and message. Just that here I called it account info, so I need to say account info.data. And we map it to deserialized account objects. So we also want to return, or I don't do that and I make it a for each. And for each I just print. So if I do this, then I should just get 10. But first I get all of them, but with an empty buffer. And then for the first 10, this is a test, admin to learn, classic ASDA, we get the actual messages. James! I'm mostly here for the vibes, but I'm also building this course. Oh, that's nice, James. Which is pretty fun. Some parts of Solana dev are tough, but well worth it. Yes, James, you're absolutely right, James. I totally agree, James. You're doing well. Ordering accounts. Now he's talking about, in this case that we had here, right? We just get the first 10, but they are still pretty much random. Or is it a timely thing? I mean, that's pretty much the RPC's choice which accounts it gives me. Maybe it sorts it by the time that they were created. I have no idea, but essentially we can say the first 10 that we get here are random. Maybe for a proper pagination, we want to sort them somehow. That's the example James gives here in this paragraph, where there are first names in the account data somewhere, and we want to sort by first name. So we need to get all of the first names, and that we can also do by using this data slice and just receiving the first name. And so we need to know where in the account is the first name. So we need to know the offset, and essentially we do that by skipping whatever is before. So here we have 1 byte and here we have 8 bytes. So we skip 9 bytes, start retrieving stuff there. Then we just need to say, well, how much do we want to receive? And, you know, for ordering, it should be enough to receive a few characters. James picked 15 per random here, which covers most cases. You could even do like 4 or 5. Anyway, so that's how we would then do it. I mean, I don't have a program that has phone number, first name and second name, but I have a program that has name and message. So we might as well sort it by name. So if I were to do that, I could do here where I provide my config, the data slice. I now set the offset to 1 because I just want to skip this 1 byte for the Boolean, and I'll get, I don't know, the first maybe 6 bytes. No, I need more than 6 because 6 would only get me 2 characters. I actually need, if I wanted 6, I would need 10 bytes because it will give me the length of the string as well, which actually, now that I'm thinking about it, I could skip as well. So I could just make the offset 5 and then get my 6 bytes because I don't care how long the string is. I'm assuming it's always at least 6 characters for my sorting. The actual decoding happens later anyway on the full data. All right, so what does James do here then? He gets that and then he sorts by comparing the... So James does read the entire string and he assumes that with 15 he has enough length, and then he compares those two strings, which is fair enough. You can do it that way. I'm just gonna ignore the length and just compare the first few letters of the name. That's how I'm gonna do it. So we get program accounts with this config, and then we sort them. We ignore the length and we just slice it from 0 because I don't receive the length, right? I skipped that as well. Actually, I don't even need to slice it. I take the entire thing. I don't care. And I just compare the two. Make it as simple as possible. And then I map them, and then I slice the first 10. So I get the first 10 names alphabetically. Let's see if that actually works. Sounds good. We have some empty ones, which are alphabetically early. Then we have some numbers. And then we start with A, A-N, Andy, Andy JS, V2. Hey, hello. Solana is a better network to collect NFTs, tokens, dev things, blah, blah, S2. Totally agree, Andy. Cheers. Arnish is here as well. And then there's Ben. So, you know, those are the first 10 names. Cool stuff, right? That works pretty easy. And if you don't understand why I added the 4 here and stuff, watch the previous video at part 5. Right at the end, I went through in detail how each string or vector is represented. So that's why I want you to have that in your head, such that you understand what's happening here, right? Such that you understand why he's slicing the first 4 bytes off here. Like if you actually wanted to, you know, work with the data, you obviously need to properly deserialize it. But if you just use it for pagination, then whatever. My opinion, personal opinion, you can have your own. For now, we still retrieve all of them, just with less data. If we add filters, then we don't even retrieve all of the accounts. So the filters have two things. For one, they have memcomp, which is memory compare. So at a specific point, again, we can provide that at an offset. We can say we want specific bytes, like we're searching for a specific name or a specific address. That was literally the way how you got all the NFTs from one collection. You were doing a getProgramAccounts and specifying a memcompare with the offset for the first creator and then the bytes, the public key of the first creator. That's how you get all the NFTs in one collection. By now, you can do it with the collection. By now, in the new standards, there's a collection field inside. But anyway, we still need to retrieve all the accounts. Never mind. Not so important. That was just an example. Point is, we can now search for specific data. And again, that's the RPC's task to find those specific accounts that you want to have. So the RPC needs to search. There is a limit to how many bytes you can specify, because obviously the RPC has to compare each of the bytes for literally all of the accounts of this program. A public key is 32 bytes, so you can match for 4 entire public keys after each other. Of course, they need to be right after each other in the account structure. So that's the one thing that we can filter for, specific account data. We can also filter for data size. So that's the entire length of the account data. Why would we want to do that? Well, because a program might have different types of accounts and the types might just differ in length. So for instance, the token program, that's a great example, has token mint accounts and token accounts. And since their structures are different, they have a different size. Therefore, if you wanted to get just all of the token mints, you can filter with the data size and specify the length of a token mint account. Because in the standard token program, that's always the same length. In the token 2022, it's variable because we have all sorts of models, but that's a whole different story. Example, we want to use this memcompare. In our example, we get program accounts for this program. And then with the offset here, we have some search string. And we need to provide those bytes, obviously, encoded. So in base 58, something here must add the length because otherwise it doesn't work. I would now do this as an example. And maybe we just want to find anything that starts with Andy. Keep it simple again. I'm not going to provide a data slice. Like I want the entire thing, but this time I'm going to add a filter, a list, and those objects can each have a data size or memcopy. And so you can have several filters at once. I can compare this one thing here and this one thing there. Cool, didn't know that. So we just want one filter, this memcompare for the offset of, what did we say? So we skip the first bool and we skip the string length because I again can't be bothered for comparing string lengths. And then we provide the actual bytes, which is just my buffer from Andy. So we do need this base 58 encoding. So let's use this library. I'm comparing for Andy. And now just to learn, I want to output what this shows me because I don't think that the length of the string is also encoded in here. Let's do this. An error. Okay, so that's Andy encoded in base 58. So we have 1, 2, 3, 4, 5, 6 characters. I don't think that it encodes the length. Also, I don't think that because it correctly matches my Andy thing here. It's not mine. Some other Andy Jizz wrote that message. And there seems to be only one name starting with Andy. And yes, we know that there's just one because we sorted them by name earlier and there was just one Andy. So yeah, but it correctly gives me this one account that starts with Andy. So essentially, I had to put the offset also for the string length. James, I propose that this is an error because you do want to add the string length here if you compare for an exact string. You want to add 4 here. If you here have the 9 and then you add 4 where you start your string, then I would expect that you had used the 13 here. That's fine. We're setting the offset to 9 because that's where we determined previously the offset where the first name starts in the data layout. Yes, but you need to ignore U32 that represents the length, which you explained to us earlier that there is a 32-bit integer that at the start to indicate the length of the data. But we, since we are so smart, know how this stuff works and put the correct offset. And that's why we can match this, which is great. We can also match for other names. Now let's get anything that Arnish published. And those are 2 messages. Learning Solana to build all things NFT. And speed! This is how you use filters. I mean, you can now also try the thing with the data size, but since in this case we have just 2 variable length strings, it doesn't really make much sense because they're all different size. So there is no real good use case to search for the length of something. Not even searching for where the message is 0, because still have the variable length name before. Like if that was a static one, then I could at least search for if the message is 0, but I can't. And also that's the next thing. If I were to want to search for the message, right? So if I want to match the message or even just the length of the message, I cannot do this with this data layout because the name is variable size and I need to have a fixed offset. I can't work with a variable offset. I can't say, well, find the beginning of the message here. That's not how this mem compare works in the filters. And that, by the way, is also the reason why Metaplex decided that those strings have fixed length, as we discussed last time. Because when they have fixed length, then I can do the mem compare on the creators down here because I know the fixed offset for the creators. So yeah, memory layout is an important topic when it comes to Solana. It's not just, yeah, put whatever you have after each other into your struct. No, you should actually think about it, what consequences that has. And just as a general rule of thumb, put all of the variable length things rather at the end of the struct, because then at least for the fixed size things you can do the mem compare filtering and you can do the direct accessing with just the offset. Yeah, so just some tips here for you. Okay, cool. And that's pretty much all of the theory, right? We can fetch just some slice of data with which we can then order, sort for pagination. We can use filters to get only specific accounts back. We can filter and just get a slice or nothing at all in this case. Just the public key for the accounts. And yeah, that's pretty much all that there is to discuss. Now to the demo. So the demo we're gonna do together and then the challenge you can do by yourself. So we work on the movie review app again, but this time we're gonna add a little pagination. So we once again go to our Solana movie front end. We changed something last time, so we git stash that real quick. And then we can git check out, what was it called? Solution deserialized account data. There. I'll copy this part. Is set up to track remote branch solution deserialized account data from origin. Perfect. So it takes the thing that we need. Now, if we npm run def, then it starts as the server, such that if we go to localhost 3000, we get this nice little app. And it's again everything that is in here. The movies reviewed. And that's quite a lot by now. So we want to paginate this. So let's add paging to the reviews. You put it in coordinators, new folder. Coordinators. This part I'm still okay with copying. This part I'm also okay with copying because it's literally what he says that we do. Might as well get the Web3 from Anchor, which is the same thing as the Solana Web3 anyway. So now the implementation of this I want to do by myself. The prefetch should get us all of the accounts of this program and then set the static accounts to this list. I can do that because I already did. It's essentially just a getProgramAccounts for, call this address, and the program ID be the actual public key of the movie review program address. And then here use the movie review program ID, which is the pub key. And the config is, again, we don't want any data, so we put offset and length to 0. And then we get the accounts, which we can, maybe not call that accounts, I call that account infos. We set our accounts to account infos and map each of the account info object to their public key. Easy. And that is all that prefetch account's supposed to do. Yeah, that's exactly what I did. And then, so we need to get the right keys, and then we get the accounts for that. And then we deserialize the accounts and return the corresponding movie objects. Okay, we can do this. Let's do it. So we have a connection and we need page and page per number. So the thing we want to do is from the connection get multiple accounts info, which again needs a list of public keys. So accounts to fetch. And I want all of it, right? I don't want to have just a slice of it. So I want all of it. So I don't need to provide any more filter or data slice or anything. So I just want all of those accounts. I'm going to await that. So which accounts are those accounts to fetch? Well, we have the this accounts. We're going to slice to just get the accounts we want. And we're going to start by page times per page. So entries per page times the page is the start. So if we have page 0, then we have 0 times however many we want. And the offset has the end or the length. It has the end. So we need this again, but page plus 1. And the end, as far as I understand at the slice, is exclusive. So I can do it like this until the next page, not including the first element of the next page. We just slice it. So this will be my accounts to fetch. And then we actually fetch the accounts. We return the account infos map, and each account info we map onto a movie that we deserialize from the account infos data. Let's do another step. Const movies with nulls. And then I just need to filter them. Okay, and I also specifically need to say that I need this as a movie list because I'm now sure that I don't have nulls anymore. So that should return my movie list. Fine, so far so good. Let's see how we did. Oh, so James has the page start at 1 and not at 0. It's the same thing, just with an offset of 1. So and make the -1 here. If you want to start with page number 1, fine. If the paginated pub keys length is 0, he already returns, but I still annoy my RPC server anyway. And he uses a reduce. Reduce is also a possibility. So you have the previous movie list, and then you add the current account, and you do this for each of the accounts, and each of the accounts you deserialize. So the data you deserialize in movie, so that's what we did. And here he filters. If it's null, then he just returns the previous list, and if it's not null, then he adds the movie to the previous list. That's a possibility how to do it. Fine, I understand how it works. If you don't understand it, learn TypeScript. But that's not Solana specific, so we're not going to dive into detail here. But it does essentially the same thing. Return movies. Cool. Manually, I'm just going to copy his code, I think. We go to movie list. So here we add a set page and another effect that when the page changes or our search, then we want from our movie coordinator, we want to fetch the page, and we have 10 entries per page. That about makes sense. We need to add buttons. Now that is front end. I don't want to do front end, so I'm just gonna copy this code. We have pages, and then with set page, we change the page so this effect takes effect, and it actually changes. We change the return to not just return our movie cards, but actually have movie cards that we get from this movies. But there's a button with click. We start with page 1. Actually, why do we say that we start with page 1? Here we say we start with page 1. Then we set page +1 if we hit next, and -1 only if we're larger one. Otherwise, we don't do that. We don't show the previous. So I can read this front end code. I just don't want to write it. Looks good. Now, does it actually? So for now, we keep it with just the page. We don't want to search for anything yet. If the page changes, then we want to fetch the movies and then set movies, which takes the movie array. So that what comes back from here, that already is then awaited with a then and then set. I think that does that automatically. So let's see how that looks. Compiled successfully. Let's go here, refresh just for fun. And boom, so we have still a lot of stuff here. This doesn't work. Okay, cool. The way I would write this code is like this, except I can't await in here. Ah, yeah, that was the problem. Damn. So let's do it with then. Set movies does. I mean, I think it already does that automatically. I don't need to specifically write it like this, but maybe. Nope, same thing. Ah, here. That's one thing I didn't do, right? Because I thought it was called from outside. But he calls it actually in the coordinator, in the fetch pages. If we don't have accounts yet, then we want to prefetch accounts. Okay, well, that makes more sense. Cool. Let's do that as well. And go here and refresh. Yes! Yeah! We got the first 10 accounts. Nice. And we can click next. And then we're on the next page. And we click next. And we're on the next page. And look how quick that is. I mean, it loads always just 10 accounts. And we can click through that stuff. Here we have it. The Andy Solana Dev Course Part 2, which is super shit. Good that Part 6 is much better. Yeah. Next up, we want to order the reviews alphabetically. And then we also want to add a search. Basic search capability. See, that's where this search that he already had here comes in. If you look at the reviews, you might notice that they are not in a specific order. Yes, yes, yes. And we want to bring them in a specific order. Yes, yes, yes. Remember from last time, this is the layout. We want to sort it by title. I can do this. So in the coordinator, modify the prefetch account to get the title and sort by title. We are going to take the offset of 1 byte plus another byte plus 4 bytes of the title, because I can't be bothered to fetch the entire title length. So 1 plus 1 plus 4 is 6. And we say we just sort by the first 5 characters of the string of the title. I don't need to sort better. That's perfectly fine from my great front-end app. And then we get those account infos. We now want to sort them by comparing what is there. So we alphabetically sort them, and then we just have the alphabetically sorted in this accounts. So if we do that and we go here and we refresh, yeah, we start with the dot test 0000110, and here we need to have Andy Solana Dev Course and Andy Solana Dev Course Part 2. Part 6 is much better. The last thing we want to do. I didn't do it as nicely as James with the getting the entire string and fetching with the length of the string. I just compare the first 5 characters. That's fine with me. We want to improve this by adding a search to the prefetch accounts. We use filters and we offset the title such that you can search by title. Okay, cool. We're gonna add a search string, and then we want to add a filter here. So we add a filter. The offset is the same as we had before. So the offset we say is 6, and the bytes is buffer from the search. And this entire thing we need to base 58 encode. And this library we need to import. And I think that should be it. We just filter for this as well, and then we only get those back. We also sort by name now. Anyway, so that's the tough part. See, now he has the offset of 6. Now he has it, right? Now he adds the 4, right? James should also add that at the top here. Anyway, the other way to do it is how I would have thought this would work, by not prefetching from here, but prefetching from the movie list. So doing here a movie coordinator prefetch accounts with my connection and my search string. Then I avoid putting all of that stuff as well in the fetch page. And we want to add the search like this. And then we add the search here as well as we had it before. And that should then probably be it, except we also need to define some search somewhere. First, let's see if that still works. If I refresh that, in the center, and that's front end that I don't want to deal with. So we have just an on change. We set the search to the target of this input. Okay, that's cool. We just copy this code and then refresh this page. Then we get this nice little searchy thing, and we can search, for instance, for nothing. Then I get, oh, it updates every time after I type. Oh, now I'm searching for nothing. Andy? This is not working so nicely yet. I need to type the next thing that it updates. But again, that's a front-end issue. I can, with typing Andy, all of the titles that start with Andy. And when I remove everything, then I still search for A. So something doesn't work. The on change, set search. I'm still one behind. This doesn't trigger at the right point. Andy. That's front-end stuff that I don't want to fix now. I'm happy with that. I would say we totally did it, and that's it. We support ordering, we support paging, we support search. That, ladies and gentlemen, is all of the front-end stuff, or is all of the basics of, client interaction with Solana. So all of the front-end stuff. I think we're good here. Boom. I think this was fun. You do the challenge yourself. And me, I'm gonna make the next video. First, we're interacting with common Solana programs. Okay, so we still don't start to program. We're now interacting with programs that are already there. So far, we just had James's movie review app. So those, we were laying down the basics. And then we're gonna interact with the token program, the token swap program, and create NFTs with Metaplex. Yeah, stuff you might want to know. Subscribe to stick around for the next videos, and I will see you in the next videos. You can also check out previous videos here, like this video, and let everybody know that you enjoy my content. Until then, bye bye.